Okay, welcome back to another video, and in this video we're going to look at the second Arduino project that we're going to work on. And it's going to be a little bit more complex because in this project we are going to have two Arduinos, and each one of those Arduinos is going to have a separate code on it. But these Arduinos are also going to be able to interact with each other. So we can say that we have a host and a partner Arduino, and with each of these devices they're going to do independent tasks, but they're going to do them simultaneously. Maybe think of this as doing things in parallel. And the reason that we would want to do this is simply to divide and conquer tasks, and that's going to help us optimize speed of the program. Now, in addition to having a host and a partner Arduino, we're also going to interact a little bit more with the serial monitor. We looked at that a lot in the first video. But now we're going to need to take in some input into the serial monitor, so we're going to have to learn how to do that. So if we look at what the outline of the project might look like, on the left here we have the PC and serial monitor, in the middle we have our host Arduino, and on the right we have our partner Arduino. So the serial monitor is going to prompt for some input. We would input something, and then from the serial monitor this would get relayed to the host Arduino, and based off of the input, two things are going to happen. The first thing is going to be a computation right here, so that's going to occur on the host Arduino. And then in sequence, we would send some kind of data to the partner Arduino, which would trigger this LED animation. So we would have this computation here and this LED animation happening at the same time. Now after this computation, there's going to be some result, so we can store that. But we're also going to be checking for completion of the animation. So after the animation, this partner Arduino is going to relay some information back to the host that the animation is done. So we have kind of a makeshift AND gate here. And then once this check for completion is done, it's going to relay some information back to the serial monitor, which is going to output our computational result. So if we try to think about what can we do for our computation, well, we could make that computation do any complex function or equation. But no matter if we use a simple or complex function for this mini project, it doesn't change what we're trying to accomplish with this project. So let's make it simple. And let's just have the computation be a square root function. Now we've seen this before in Visual Studio where we used the Babylonian approximation. Maybe we should cross out function here and put approximation or method. But we don't actually need to use this for the Arduino because there is a built-in function that makes everything work nicely. And if we look at the LED animation, we can really do whatever we want. We have a lot of freedoms here. We could sequence them on, we could fade them off. Maybe we do both. And then we're going to have to ask, how do we power the LEDs? And in the last video, we saw that you can power them directly off of the Arduino. While that might not be the best way to do it for extremely low currents, it's okay to do so. Just remember not to exceed this 20 milliamp drive current if your partner Arduino is the Arduino Nano Every. So scrolling back up, we know what our computation is going to be. We know what our LED animation is going to be, roughly. So the next thing is probably working with the serial monitor. And we have a little bit of new stuff that we have to learn, but we have some things that we know that we will also be using. So we have this serial begin, so that's going to set the data rate in bits per second for the serial monitor. We have this serial print line of code that we can have, so this is going to print whatever we want to that serial monitor. We can have the modified serial print and do serial print line, where the line is just represented here. So this is going to print to the serial monitor with a new line. So if we look at what we don't know, well, we don't know how to use the serial monitor to get some input. And we don't really know what the input is yet for this project. But if our computation is doing something like a square root, we probably want that to be some number. So that input could be a number, could be a string, character, whatever we want. So if we input a number, we have another line of code that we can use, and that's going to be the serial read. And what serial read is going to do, it's going to return the first byte of whatever was entered into the serial monitor, or it's going to be a -1 if nothing was in there. Now there is a little caveat to this, and you might think that this first byte might work pretty well, but with that first byte, there's no conversion of that byte. So the value actually defaults to the ASCII representation of that, and we don't necessarily need to jump into the ASCII table for all characters, but we do need to know that this ASCII representation would mean if we entered a 0, it does not actually map to 0. So a number might be a little bit problematic. So maybe we go with our second option, which could be a string. So modified from the serial read line of code, we can have serial read string, and this is going to read characters from the buffer. And again, we come back to this buffer concept in this course. So if we have some input from the serial monitor, once you hit enter on it, it's going to get stored in the buffer, and then it gets read. Now, if we want to filter that string, we can use this serial read string until. So this until will try to seek out a defined character. And in addition to this, we can actually set the timeout using serial.timeout. And if we look up above to the example with a number, we said that we get a -1 if there's no data entered. Well, we have to have some timeout condition that actually checks if data was entered, and if it's not, then get us that -1 value. And by default, I believe this is set to 1000 milliseconds, but we can actually define it to be whatever we want. So it looks like using a string seems pretty okay to use, but when you realize that our function, again, is the square root, it's probably going to be a little bit difficult to find the square root of a string. So if we use a number, we get a problem. If we use a string, we also get a problem. So we're going to do something a little funky and use both for demonstration purposes. So this brings us to this .toInt line of code. And what this is going to do, it's going to convert a valid string to an integer. But if you have something like the letter B, it will return a 0 because there is obvious difficulty in assigning the letter B to a number. So the way that we're going to do this, we're going to use the serial monitor to ask for a number. And the user doesn't need to know that the number is going to be stored as a string, but that's what we're going to do. Then we use this .toInt to convert that string to an integer. And then once we have an integer, we're going to call a function with that integer. And that function is going to do the square root operation. And all of this is happening on that host Arduino. And this gives us a general picture for what we're going to be doing with that host Arduino. But once we classify that input as an integer and we do our function that we call, well, we need to relay some information to the partner Arduino to start the animation. And the question that arises is, what is the best way to relay that info to the partner Arduino? And the latter and the first one are a little bit beyond the scope of what we're doing here. So we're just going to use this trigger or wake up functionality here. So how we can do this, if we use this trigger option, well, we're going to have an output on the host Arduino. And based off of when we receive some input, we're going to pull that output high and then low. So assuming that the Arduino pin would start in a low state, the output is just a pulse. And the partner Arduino that has an input pin that we define that's connected to the output pin of the host, and that's going to be watching for this event. Now, if this event occurs, well, then we're going to start the animation. And then once the animation is done, well, we're going to trigger the host that the animation is done. So then we're going to have a different pin be the output for the partner Arduino that again is just going to send this pulse. And we'll have an input pin on the host that is monitoring for this condition or event right here. Now we can get back into the project outline. Now in this project, our partner is going to be the Arduino Nano Every, but for the host Arduino, we're actually going to be using the Mega 2560. And if we look at the data sheet for the Nano Every, we've seen this before. So we have our digital pins on the right here, our analog pins on the left. Here they actually stuck another digital pin, D13, right here. So I may have actually missed this in the last video. And then if we look at the 2560, you can see here it is a bigger device. There are many more pins here. Not only do we have a column here and here on the left, we also have this bottom row of digital pins. So we have a lot more capability and more interesting, as we'll see in later videos. We actually have several communication channels that we can use. So just minimizing this screen, we can return to this project and we can start to think about how we can structure the workflow to have the least amount of headaches. So we probably don't want to write both codes and then try to debug everything at once because there's too many potential errors that could exist. You don't really know where that root cause of the problem may be. So we're going to start simple and then build up. Now the simplest thing is going to be that LED animation on the partner Arduino. So we can write some code for that and then we can validate the functionality. Now the functionality validation doesn't need to include that entire animation for exactly what we want. So it's just functionality. Can we make an input, trigger an animation, and then after the animation, do something to an output pin? After we validate a method for doing this, we can move on to the host. So again, basic functionality. Then we can actually combine the systems and start to build some code for the interaction between the two, and then test the functionality. And after we get all of this basic functionality working, then we can develop the complex parts of the code. And you would try to do this piece by piece. As you implement a new part of your code, you would debug and fix it, and then you just repeat this loop until everything is working as desired. So a few new concepts we're going to be using in the next video where we actually design this code, implement it, and then build the circuit and test the functionality to make sure everything's working. If you learned anything new or useful, please like, comment, share, subscribe, and we'll see you in the next video. Thank you for watching.